Hello viewers, welcome to my channel PC Geo Kimberlite, a source of diamond. Today we are going to see an important topic from micropaleontology, how to recover the microfossils. So recovery of microfossils from the matrix. I am Dr. Sajid Undekar, Associate Professor and Head, Department of Geology, Anjuman Khairul Islam's Pune College of Art, Science, Commerce, Camp, Pune, Maharashtra, India. It is affiliated to Savitribai Phule Pune University, that is SPPU Pune, and formerly it is known as University of Pune. Those who are the newcomers are there, I can tell them that already I have been uploaded many videos on the micropaleontology, paleontology, stratigraphy, structural geology, then the how the 5 BSc practical, the first term, second term, that is the meteorology, crystallography, megascopic minerals, microscopic minerals, then we have the maps, then we have the reading of topo sheets are there. So these are the things which is already uploaded on my channel PC Geo Kimberlite. In addition, there are number of scholarships I am going to upload it now on the various categories sponsored by the multinational companies, the public sectors, private sector companies, in the various folders, that is school folder, then junior college folder, then NEET folder, then under the graduation, non-professional graduation, that is BA, BSc, BCom, then the PG non-professional courses, that is MA, MCom, MSc, then engineering, then PG engineering, then medical, then PG medical, then diploma, IT, then nursing. So these are the varieties of the scholarship which are there. Here it is the scholarships for everyone. No caste, creed, and religion has been criteria for that. Only two criteria. One is the income, and second one is your merit. If you have been fitting, you can apply right from first standard to the postdoc. There are number of scholarships are there. Earlier one, there are the scholarships are not available, but now as per the government of central government of India, now 3% of the profit the company has to share for corporate social responsibility. So there will be scholarship will be started, or there may be the funds will be given as a donation to the medicine, medical or medical equipment, or for the medical expenses. So these are the thing are there. So those who are interested, they can go to the my channel and check it out as your interested subjects or topic which are there. So now let's start with this is what we have. So today we are going to see this particular the separate recovery of microfossil in the term of introduction, then breaking of samples, deeping of sample for disintegration, then decanting, acid treatment, dehydration and decomposition, recovery from shell. So we are going to see one by one. So this is a soft rock, that is a recovery from soft rock, then recovery from limestone, that is a special technique is required, and recovery of fossil from coal, and that is a maceration technique. So this is the way you are going to see today's topic. So the micropaleontology, that is laboratory technique for the separation of microfossil. First we'll see the introduction. After the rock samples containing microfossils brought into the laboratory. So when you are planning for have this particular microfossil sample collection, so we have to give the thoughts. So that is already we have been discussed in the earlier videos also. So that sample we have been brought from the field. Now, once you are brought into this laboratory, it is necessary to separate the microfossil from the rock. We could not see because they are not have the very fine sizes there, so we could not see with your own eyes. So now we have to have some treatment which has to be make out for the separation of microfossil. In case of hard and indurated rock, that is the example limestone and sandstone, different mechanical or chemical treatment are required. If the sandstone limestone is there, they are the different mechanical strength is there, chemical treatment is required to release the microfossil from the matrix. These include pulverization, that is a breaking, deeping in water, boiling, dehydration, decomposition, screening or sieving will be there, and acid treatment. So one by one we have to go for that particular process. Before pulverization of such a rock specimen, it is recommended that at least some thin sections are prepared to understand the nature of the microfossil, composition of the cement or matrix, or the extent to which the rock has been modified due to the diagenetic changes. Now, the second part, we are going to see how we are going to break out the breaking of sample. The first step involved in a separation of microfossil from the rock sample is to break them into the pieces of not more than half an inch with either a rock splitter or with a pith or with the help of the mortar or pestle. So we have to make the breaking down of the rock sample into half inches. We have to make out. The second step involved the disintegration. That the second step involved the deeping of rock fragment in cold or hot water. Initially, we'll make out the we'll deep into the cold water, sterilize normal water, sterilize for 24 hours, then wash it out, and with the sieve again check it out if whether it is separated. So we have to go on that method, whether it will be a soft rock, mudstone, chalk, or siltstone is there. For them, this is the first simple method. If sandstone and limestone is there, then we have to take for a few days. Sometimes we have to boil the water, then make that process has to be repeated to make the minimum wear and tear. So this process is a tedious one, longer process, but with the utmost care we have to do this particular separation technique in the laboratory, because once you have gone into the field, a lot of cost, a lot of patience, everything we haven't brought. Now once you have brought the sample into the laboratory, no need to make the hurry in separation of this process. Step by step we can go it out. First, you know whether the whatever the sample rock is there, whether it is a soft rock is there or hard rock, then we will make out that particular process will be made. But simply first one will deep this particular sample, whatever the sample we have brought, say 1 kg or 2 kg sample we have brought. Out of this we'll just take the 500 ml 500 kgs, and we will start the process. What we have, the 1/4 sample will take it out for that particular process, deeping into the water, cold water, wash it out 1 or 2 times. We'll see under the microscope, see, check it out whether it is separate or not. If you don't feel it is not separated, then 1 or 2 times you can make out. So that process, if it is still it is we feel it is hard rock, then boiled water has to be done. Yes, hot water, keep it for hours. If the sandstone, limestone, shale which are there, so we will take 1 day or 2 day we have to make it out. Now soaking in water leads to the desegregation of the sample, but a fine, but it is a time consuming process in case of more indurated samples. Keep this in mind. Ultrasonic devices are recommended for disintegrating these samples. Boiling the sample also help to separate the mud, but see that whatever you have been looking for a sample, whether the microfossil, what will be, whether it is completely fossilized or whether we are going to have the shell of that particular microfossil is there, then we have to take how much we have to boil that particular water. That is also very important. For a purpose of boiling is done with a 50 grams per liter of washing soda or a suitable subless what we have the detergent we are going to use, that will be not going to make the wear and tear, chemical wear and tear of that sample. Separation of microfossil from the indurated rock sample require a good knowledge of chemical reaction. Yes, which particular sample which are there, what is the nature of that chemical composition of that matrix is there or the rock is there, and what will be the nature of that particular microfossil is there, and what chemical we want to take it out for the disintegration. That is a very important one. Otherwise, it should not happen that once you have been putting that chemical, whatever the microfossil is there completely dissolved or it is disintegrated. So that should not be happen. So be care taken has to be taken at that time. Now next, what we have the decanting. As the mud go in suspension during the boiling, it is pour off the pans are again filled with the fresh water. That is the repetition we have told you. It is repeated until the residue turns clean. Yes, you will get the idea that whether whatever the sample is there, whether it is clean or not, we just make it out. If it is not there, one or two times, three times, four times, you can make it out that process. Expel the water is made to pass through a fine mesh of sieve so that the finer microfossils are retained. Then whatever the sieves we are taken, make it out. Then we have to make the dry, and then we have to make out under the microscope. The residue is finally poured into the sieve. The finer material is flushed gently away with the spray nozzles. Then, if it is separated, then pick up and keep it out somewhere in the trays. Now, next one, acid treatment for liberating microfossil. Now, if we do this one, and then we find out that the microfossil is not easily separated out from this particular thing, then we have to go for the acid treatment. There are the various acid treatment methods are utilized in recovering the microfossil from the sample. Some prominent chemicals utilized for the specific type of rocks are below. Yes, that is very important. For this particular technique, we should know, I told you in the beginning, what will be the nature of the test of that particular microfossil, what will be the nature of the rock is required. Then only on the basis of that, we have to take a particular acid test. For example, argillaceous rock, whether it is a shales or mudstone. If you know that these matrix which are there, they are of a shales or mudstones are there, in which the particle size are less than 0.01 mm, and for soft limestone, the we can use the kerosene or turpentine. It is advised for the disintegration. The use of a detergent or bleaching powder is also recommended. Acid treatment for liberating microfossils for the carbonated rocks. Yes, that is a very important. The use of dilute HCl, acetic acid, oxalic acid, or phosphoric acid is recommended for the carbonate rocks. Dirty rocks contain chemically resistant SiO2. Quartz is there. So the use of CAF or HF we can use. H2SO4 is advisable when which liberates the siliceous matter when the fumes of hydrochloric acid dissolve silica and bring about the disintegration. The other acid which are various combination can be used for the liberating the microfossil from the rock matrix are HNO3, H2SO4, NaOH, HF, KOH, and NH4OH. But while you are going to use these particular chemicals, keep in mind these are the very strong what we have, the acids are there. Use the proper gloves and take care of your skin as well as your face. You should not be exposed directly to these particular acids when you are going to use them. The disintegrated samples obtained either by mechanical or chemical means are first subjected to washing with distilled water in order to remove the finer fragments or the particle. The washing is normally carried out through a set of sieves with the size of 10, 33, 60, and 200 mesh. Below 200 mesh sieve, a pan is placed to recover the tiniest microfossil, especially the nanoplanktons. Each fraction obtained on the sieve is dried in an oven at a 50-degree and before picking and separation of the microfossils. Vegetative matter is often commingled with the microfossil when thick sediment piles are deposited. Hence, coal seams often have a number of organic compounds as organic impurities. These impurities need to be separated from the microfossils. That is the dehydration and decomposition. A process of dehydration and decomposition is therefore required. The process of dehydration liberates nitrogen, oxygen, or hydrogen and other volatile matter. A coal seam often contains abundance of pollens and spore. So we are going to get abundant quantity of pollens and spore in the coal. Depending upon the quantity of coal, whether it is pit, lignite, bituminous or subbituminous or anthracite variety, different concentration of chemicals are used for dehydration. The decomposition of sample help in solution of calcareous matrix into which microfossils are embedded. Depending upon the chemical nature of the sediment, it is also require acid of varying concentration for decomposition process. Recovery of microfossil from ordinary shale, siltstone, soft calcareous shale, semi-consolidated sediments or claystone, or simply we call that it is the soft rock. From we can recovery of microfossil from the soft rock. The rock sample are fragmented into the pieces of 1 to 2 centimeter and less than 2 to 4 millimeters. Crushed material is then taken into a metal container containing 1 liter of distilled water and allowed to soak for 1 to 2 hours. Once the sample is disintegrated, the mixture is stirred and allowed to settle. Then it is decanted. The process is repeated till the water poured off is clear. Once we find out that whatever the water we are pouring, it is a clear, that means the sample is clear, the mud has been cleared from that particular sample. The wet residue is then dried on hot plate under observation, because if you heat more than whatever the fossils are there or shales are there, they will be just broke it out or disintegrate. Then there is no use what we have done. So we have to carefully do this particular exercise. Then screen through the standard sieves 10, 35, 60, 120, and the mesh contained each sieve is then transferred to separate plastic bottles and number each fraction. This is the very important. Once you are doing this separate or separation, start from 10 or whether you can start from 120. So whenever you're taken, write down details has to write what will be the sample number is there, and what we have the sieve number is there, then whatever the date is there, you can mention all the records on that plastic bottle and number of each fraction contained is observed separately under. Then we have a separation, we can do it on the later on. Some petrologists prefer wet screening with nozzle spray water to flush series of screen. In some cases, dispersing agents like sodium bicarbonate, sodium hexametaphosphates, sodium hydroxide, or even stronger agents are used to disintegrating the sample. Jones has suggested to boil the rock fragment into solution of photographic hypo. After boiling for some time, the mixture is sprayed in shallow enamel tray till liquid hypo evaporates. Formation of hypocrystals lead to disintegration of rocks. To recover conodones or other chitinous remains from fissile and black shales, Jones suggested to split shales into thin lamellae which can be observed under microscope. If fossils are observed, they are circled preferably by a light color pencil. Then with the dissecting needles, all matrix around the fossil is trimmed off, making it isolate and remove with the pointed long nose plier, and then fossil is placed on the slide. Next one, in that if little bit hard shells are there, then modified techniques such as thoroughly drying, heating, dipping in kerosene or gasoline, or repetition the above step to disintegrate such shells and recover the fossil. One or two times, three times, you can make this process continue till it will be clearly separated the fossil from the matrix. Now the shells containing diatoms and dinoflagellates. Fragments of such shells are boiled in concentrated HCl for about 15 minutes. Then without washing, the fragments are kept in a concentrated HNO3 and boiled for further 15 minutes. After thoroughly washed with the water, it is again boiled in concentrated H2SO4. The quantities and everything will be given in the charts, so those who are there, they can refer the whatever the separate book is there for the separation of microfossils. The material is then washed and boiled with NaOH for 5 minutes to disintegrate it and neutralize NaOH. Few drops of HCl are added after cooling, and remaining samples are pipetted out and taken off by dropper and kept in a water glass to evaporate it. A small drop of pipette sample is kept on the glass, a clean glass slide, and generally gently sprayed with the distilled water and allowed to evaporate. Then a drop of mounting medium Cyrax, a natural blossom, or Hyrax of high refractive index is placed on the dried sample on the slide and the glass cover slip is kept on it. The slide is then generally warmed to melt for even spread of media. The slide is then observed under the microscope. Dark organic marine shells. Yes, there are the categories we have been done. So, dark shells and brown. Yes, that is dark organic marine shells we are going to take. The dark shells are broken in small pieces about zero point 0.5 centimeters and kept in a copper beaker containing 52% of N hydrochloric acid and allowed to digest for 16 hours. Yes, when you keep for 16 hours, see that when you have been starting this particular practical, after 16 hours, it should not be coming in the late night or it should not become early in the morning. So normally when you're coming into the lab, whether in the morning 7 o'clock, 8 o'clock, 9 o'clock, so your 16 hours should be complete within that particular, so that you can get the sufficient time for the process, which is after that process you can make it out. So keep in mind. The residue is then diluted with the distilled water, centrifuge, rewashed, and centrifuge thrice. Yes, that is there. So that is a very important. The residue left after centrifuge is mixed with glycerine and, if possible, stained with light red dyes and observed under the microscope for organic walled microfossils like pollens, spores, and the similar microfossils. Recovery of microfossils from the limestone. Yes, 100% this will be there in the examination as a write a short note. So those who are there, they can prepare. Soft rock is one. Second one is the limestone. The recovery of microfossil from limestone depending upon the chemical composition. What will be the chemical composition of the rock? We know that it is a limestone CaCO3. Now we have to know what will be the composition of the microfossil which is there within that particular limestone. The amount of silica, dolomite in the limestone we have to find out. Then the preliminary test is done. If the first option, if the fossils are calcareous, yes, the rock is also calcareous, the fossils also calcareous, then what should be the treatment we have to use it out? They will be difficult to extract from the limestone. However, if the limestone is crushed to approximately granule size 2 to 4 mm, washed and decanted certain percentage of the specimen, including foraminifera and entire osteochords, will break free of limestone. The remaining rock fragment may be examined and fossil cleaned from matrix with a fine dissecting needle. If it is advisable to leave and clean specimen in the limestone rather than risk destroying it by removing it from the rock surface, unless the limestone is much softer than the fossil. That you have to check it out. If the microfossils are arenaceous, siliceous, or chitinous, yes, these three. The microfossils, they are the of a composition of arenaceous, siliceous, or chitinous are there in the composition. Then, as shown by the preliminary test, then the rock specimen is immersed in a dilute solution of HCl, that is 10%, or acetic acid 50%, closed and allowed to digest. When effervescence has ceased, the spent acid is poured out and the new acid is again added. So that process will be repeated. This process will be repeated until no effervescence will occur. So this is the very important observation. Once you are putting the acid into that, we have to check it out that whether the effervescences are coming or not. The residue in the beaker is washed, filtered, dried, and prepared for inspection under the microscope. Drying should be done in a hot plate with the cautions. I told you that is a very precaution has to take. It should not be just heat up to the 50, 60, 70. Go slowly and see that what is going to happen to this microfossil which are there in that particular hot plates in order to prevent shattering of the specimen. That is a very important. The effervescences must not be too violent. That is also very important now. If the effervescences are too violent, break it out, bust it out, and it will be everything will be which are there. You are there in front of this what we are doing the experiment, might be your skin, your clothes, everything may happen, anything will be happen. So be careful. References must not be too violent or delicate structure be broken. That is there. But in addition, there will be a damage to yourself also. For more gentle dissolving of the carbonate rock like acetic acid, oxalic acid, and phosphoric acid. These are the very strong one. So we have to take care. The maceration technique. This is again a separate short note. 100% will be asked, and everyone know about how this technique will be taken place. Maceration or qualification, what we have, the technique will be there. The maceration means the soften, and hence the process of separation of pollens and sporins from the coal is also called as maceration technique. The separation of pollens and spores from the coal. The coal is broken into the small pieces, kept in a beaker containing slurp solution. What is that solution? Mix 1 part of saturated aqueous KCl with 2 parts of cold concentrated H2NO3 with few hours, and the humid matter is removed by the maceration. After the digestion, the mixture is washed with the water till the liquid attains a normal pH of 7. The solution of 10 KOH or NH4OH is added to the beaker to release the humic matter. A small drop of this liquid is taken onto the glass slide and observed under the microscope. If few spores or pollens are observed, the mixture is washed to maintain the pH 7, and again the solution of KOH is added to start second stage of maceration that takes about 15 minutes to 2 hours. After second maceration, more spores are released. Soluble content are washed from the residue by filtering it. The residue is then mixed with the glycerine and mounted by staining it with saffron or similar dye. Maceration method is applicable to coal containing less than 90% carbon, and by this method microfossil can be studied. I hope this is from my side. I try to clear it out. How can make the recovery of microfossil from the matrix, that is divided into the soft rock, then the calcareous rock, then the hard rock. I hope this is clear. If you are interested to visit my channel, PC Geo Kimberlite, a source of diamond, you can go and see the various videos which have been uploaded for the geology as well as NCC as well as the scholarships. Thank you. Have a nice day.